some more of your need-to-knows in your countdown to A-level. This one here on the board is probably in the top 1 or 2 of the things that we really need to remember in terms of formula. But we also need to know how to go from this and how to derive our other squared identities. And then we're going to have a go at working with them. So sine squared plus cos squared is 1. Okay, we need to remember how to get the other identities. So the first thing I'm going to do, I personally like the one where you divide by cos first. So let's do that. Sine over cos generally is tan, and sine squared over cos squared is no different. That's going to be tan squared. If you want to check for yourself, here's kind of the thinking when you're doing this one here. What you can do is you can take the power out and then change it to tan, and you would have tan squared. Okay, so yes, we are allowed to just say that sine squared over cos squared is tan squared. How about next? Well, next, cos squared divided by cos squared is, well, that's going to be 1, isn't it? You're dividing something by itself. Okay, and then I could use the identity symbol, or I could use the equal sign. Then I need to have a think about 1 over cos squared A. So when I'm dividing by cos, the trick is, well, we're going to be looking for one of these words. So cot, cosec, or sec. Which one are we looking for? We are looking for, because it's all about cos, we are looking for the one where the third letter is a C. So this is the one that we want. It's going to be sec squared A. Now, the good news is if you can remember the process of this, and I think you can, sine over cos is tan. Tan goes on the same side as the 1. This one here is a little bit trickier, but you have a good guess, and then you check. If you can remember this one here, then you're going to have a very good chance of remembering the next one. So we're going to go back to the start, and this time we are going to divide by sine squared. If we divide by sine squared over sine squared, let's use a different color here. Let's go for a 1 over here this time. So that one's going to be 1. How about cos over sine? Well, the idea with this, I like to remember, is that these 6 main trig words that we know are going to appear once. There's sine, there's cos, there's tan, there's sec. So which one is it going to be out of these? Well, you know, cos and sine, that's kind of like tan. So that's going to be cot squared A. And then the last one is a really nice one. Which letter have we not used yet? This must be cosec squared. If you check the third letter, you can see that it's an S for sine. That's how you know we've done it correctly. So these ones here, you want to know these so you're not wasting time, so you're looking out for them, so you're able to solve trig equations nice and quickly. Okay, each word appears once. Anything about tan, or, you know, cot is sort of about tan, has the 1 on the same side. I see lots of students who cannot place the 1. They get very confused about the 1. The 1 always goes with the tan or with the reciprocal, you know, which is cot squared. So we're going to have a go now putting some of these into practice. So here we are. We're going to see what we could do with an equation like this. Just a bit about the notation. This is essentially saying we're looking for 0, you know, to 2 pi like this. Don't worry about this notation too much. So what we've got to do, well, we actually have quite a few choices on this one because we've got sec squared and tan squared. But the big idea is we don't want to be using both of these at the same time. So what we do is we think about our identities. Now, I write this one down, or I remember this in my head, and then I say, what do I have to do to get, say, tan? Well, that's when I divide by cos. So let's do that now. So tan squared plus 1 must be equal to sec squared. I'm going to write sec squared there so it doesn't confuse me. And now I know this. The idea is that, well, I could change sec squareds to just tan squared plus 1, or, you know, something like that, okay? So let's have a go with that one now. So I'm going to change sec squared to tan squared plus 1. So I'm going to write out my equation again. I'm leaving this gap here because there's no way I'm going to figure this. So sec squared, so this must be tan squared x plus 1. And now let's tidy it up a little bit. Let's expand that out. 3 tan squared x plus 3 minus 2 tan squared x equals 6. Now, normally with a quadratic, you want to get everything on the same side, but this doesn't seem to have like a middle term. So let's just sort of simplify these bits first and see what happens. So that would give me tan squared x. Well, since there's no middle bit, I'm actually going to move the numbers to the other, let's move the numbers to the other side. So I would get tan squared x equals 3, or if I didn't move them to the other side, I would get tan squared x minus 3 equals 0. One advantage of this method over here is it stops you forgetting answers. Let me show you what I mean. So if you sort of, it's not the nicest number in the world, but hopefully you can kind of see where this is coming from. So this is quite nice because it shows you that we're looking for two different sorts of answers. We're looking for when tan x equals root 3, that's going to come from this one, or we're looking for when tan x equals minus root 3. You may have missed that if you do this one here, okay? But it's the same as well. So when is tan equal to root 3? Well, that's actually a special value. That's going to happen at 60 degrees. So that's going to happen at 60 degrees, which is the same as pi over 3. And then if we check our domain, it's 360 wide. So the trick with tan is you normally add and subtract pi or add and subtract 180. So the other one here is going to be 4 pi over 3. Okay, I'm adding 3 pi over 3. And minus root 3 is going to be pretty similar. It's going to be minus pi over 3, but that's not allowed. So it will be that plus pi, and it will be that plus 2 pi. Let me show you the neater version so you can see for yourself. So what were we doing? We were using our trig identities there. Okay, you've got to make sure you know them and you are very fluent with them. So let's take a look. You can see that over here we ended up getting the same solution. We've got to deal with plus or minus 3. If we do the plus first, we get root 3, okay, which is down here, and its sort of next one is over here. When we do for the minus, your calculator should end up giving you a negative, but that's not a big deal. So minus pi over 3 plus pi, that's how you get to the next one, and that's the one that we've got here. Okay, so we've got 2 pi over 3, and then if you add on pi more, you will get this one here. So 4 solutions for this one here. Let's have a go at another one. So give it a quick pause, see if you can still remember. How would you make this one all about the same trig function? Well, hopefully you remembered that there's a function that connects these together. So tan squared plus 1 we talked about in the previous one. We talked about the thing about tan or cot is always on the same side as the 1. So let's just jump straight in with that idea. So this must be the identity that we are talking about. It's easiest to use it as it is now because that is the same as that bit there. So let's jump into it. So 3, I'm going to do that in a minute, minus 1 equals 7 cot squared x, and we've got the same domain over here. So this is a similar type of question. We're just using a different identity. So expand out, and I've got 3 cot squared x plus 3 minus 1 equals 7 cot squared x. Let's move things to the right-hand side this time, and let's try leaving the numbers on the other side. So a 3 minus 1 is a 2, and if I take away, I should get this one here, which should give me 1/2 equals cot squared x. Okay, so when we're solving these ones here, what you really want to do is you want to remember that this is saying what? It's saying 1 over tan squared x is equal to 1/2. So it's okay. It's okay to reciprocal both sides as long as there's just one fraction either side. Otherwise, you're going to get into trouble. So if you think about maybe cross multiplying, okay, you're going to get tan squared equals 2. And we're looking for, because of this one here, we're looking for 2 solutions. So it's going to be a plus or a minus root 2. That's what we would solve for. Let's have a look at the neat version. So we are using our identity again. We're subbing away. There's other ways you could do it, but this is probably the easiest way. We get to our cot squared x is 1/2. And this is the same as looking at tan x as plus or minus root 2. No nice, neat answers for this one here, but if you sort of think a little bit about a tan graph, it's not too difficult to think about what would happen. So root 2, if we imagine, let's do the next version as well. If we imagine that root 2 is down here, that's going to be between 0 and 2 pi. So that's going to give you your 0.955. And then pi later, you're going to get the same thing happening. So that's going to give you 0.955 plus pi. That's what that one's basically doing. Your minus, your other one, so that's for the root 2. What's going to happen with your minus root 2, which is down here somewhere? Notice that this answer isn't actually allowed because it's said between 0 and 2 pi. So what you've got to do instead is you're going to take this one as your first answer. So where is that, you say? Well, it's this one here. I would encourage you to think of this as minus 0.955 plus pi. So that's what this one over here is. What's this one doing? Well, this is the same answer, isn't it? It's just plus pi. Okay, so it's not that unusual to get, say, 4 answers when you have a quadratic, if you have a big domain. There's one final question for you to pause and have a go at using the ideas we just said. And if you did that, you should have got these solutions on the screen. So I hope I've convinced you to make sure that you know your sine squared, cos squared identities and how they turn into these other cases here. Until next time.